We're going to simplify the following square roots into simplest square root form. And what does that mean? That means that there is a perfect square sitting in that square root that we need to try to find and take out. So let's make a quick list of perfect squares that we might want to try to use. So how do we get a perfect square? We square a number, and 1 times 1 is 1, so that's the first one. And 2 times 2 is 4. And again, we're just going to keep writing this list. I think it will be a good idea for you to get this down at the top of your paper, because these are the numbers you're going to want to try to find in your factor lists. We just did 2 times 2. How about 3 times 3? Yeah, 9. 4 times 4 makes 16, a perfect square. This is the number that is created by multiplying the same number times itself. 5 times 5, 25. 6 times 6, how about 36? 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10 is 100. And that's pretty much the whole entire list. There's a couple of numbers out there, that you can keep going with, but these are the ones that are the most popular. All right. So we got those in our head. Those ones are the ones that we got to kind of remember that we want to try to use. So 32, is it one of the numbers that we just listed? No, but it could be made up of some numbers that I listed. So let's go ahead and try that. So this is the process of trying to think of ways to multiply to 32. Obviously 1 and 32. 2 times 16, 3 doesn't go into 32. 4 times 8, the next one is 8 times 4, but at that point you're repeating yourself, so don't bother. Okay? So now, I've got 3 pairs. We're looking for the largest perfect square. Tell me that you're still there online, all right? Let me know you're still actually in the seat that is in front of your computer and you've come back from lunch. What's the largest perfect square that you see? What is it? Yeah, right. I'm not seeing that chat moving, folks. If you're still there and you can still hear me, what do you think? Even if it's wrong at this point, I just want to make sure you're still here. You're back from lunch. So quick check-in. Thank you, Alex. I do appreciate that. Now, 4 is a perfect square, but not the biggest one. The biggest one would be the 16. So we're not going to use that, and we can't use that. So 2 and 16 is how we're going to rewrite this. So we just split it up into 2 parts so that the perfect square goes first, the square root of 16, and then the square root of 2. And I know you're probably asking yourself, why in the world do we do this? Well, remember, we're trying to get something out. We're trying to get us a better idea of where this number is. So the square root of 16, what's the one number that multiplies by itself to get 16? It is 4. And then the square root of 2 follows. Now that 4 could be either a positive or a negative, because a negative times a negative is still positive. So we don't know if it's positive or negative 4. Well, ways that you can multiply to 125. 1 times 120. Ooh, you know what? This is kind of ugly. I don't know if I want to keep doing this. How about we introduce the calculator? Yes, this would be better. So if you have a calculator, time to get it out, and I'll give you a moment for that. You would press y equals. You would then enter in the number you are trying to factor, 125. And you are going to divide that by x, meaning divide it by every possible x value, which is really nice that the calculator will do that for you. Press second and graph, and you will see all the factors. Now, these ones include the decimals. So if it has a decimal, just throw it out. It's not a perfect square. Where is the largest perfect square? Do you see a number that we wrote in that list of perfect squares? 5 and 25 is what I'm hearing from our audience, and that is correct. So 5 and 25 would be another one. Not going to use that one, so we rewrite this as the square root of 25 times the square root of 5. Now remember, you want to put the square root of the perfect square first. So that would be 5. Now it could be a positive, it could be a negative, so we write it plus minus 5. It just so happens that the square root of 5 is the same number. Now, obviously, not always the case. Now, again, what does this tell us? This tells us that this right here, which is the same as this right here, is around 5. Now, clearly, it's a little bit bigger than 5, but it's around the value of 5. We've just kind of simplified that down for ourselves. All right, one more with 147. Perfect square? No. But the calculator is going to help us find the perfect square. So go back to the calculator, tap the y equals, type in 147. So you can type right over the top of this, and then because it was a 3-digit number already, it's already being divided by x. From there, second and graph, there's the list of factors. Do you see a perfect square, virtuals? My virtual peeps, tell me in the chat. Let me know you're still there. We already wrote them down. Which one of those is a perfect square? Whew, it's getting a little hot under these masks. Perfect square? There it is. Yep. Well, the participation online is making me a little worried, but it would be the square root of 49 times the square root of 3, where the square root of 49 would be 7, but we don't know if that's a positive or a negative 7. We keep it the square root of 3. All right, time for you to try D, E, and F. And again, this is just a review, so ask me any questions. So quadratic formula, it's all about finding the roots, which are really called the x-intercepts. So don't worry about having to memorize this formula. The formula will always be told to you. Reference table of a Regents exam, on any test or quiz that I give, don't worry about having to memorize x equals negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. So you can leave that just for math teachers, for ones that have to memorize that. Now, why are we doing this? Well, because we can't factor this trinomial. This trinomial is unfactorable by factor by grouping or any other method, so we've got to try to use the quadratic formula. So, with that said, we need to identify some letters. A, B, and C. It's in alphabetical order when it's in standard form, when the largest exponent goes first. So then it just becomes a bunch of substitution where we just plug numbers in. So 11 is the B value, but it's the opposite. So negative 11, and then plus or minus, square root symbol, B squared. How about 11 squared? Then it's minus 4 times A, which is 10, C, which is negative 6, and then all divided by 2 times A again. So there you have it. All I did was I just substituted in A, B, and C appropriately. And then honestly, it's just order of operations, which follow your PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. So we're going to get negative 11 plus or minus the square root. Now here's where we can start simplifying. 11 times 11, it's 121. The perfect square, 121. 4 times 10 is 40, and then 40 times 6 is 240, but that is a positive 240 because it was a negative times a negative. And then 2 times 10, call it 20. We're going pretty quickly here. We just did some adding and subtracting, some multiplying and some work with exponents. So not too bad. Now we're going to just do some adding. So negative 11 plus or minus. Square root is going to be 361 divided by 20. Now, square root of 361. I'm not sure off the top of my head. I'm sure you're not very sure about it. So let's go to the calculator. Second quit. Our worry about square roots is if it's not a perfect square, it ends up being an irrational number, right? Like we saw from the tic-tac-toe. Second, x squared brings up the square root. 361. Please be a perfect square. Please be a perfect square. Oh, it is. good old 19. So that's going to make things a little bit easier to work with. Let me get my magic grabber hand here and give myself some more room. All right. So this is just 19. So negative 11 plus or minus normal number, just 19. That's why it's positive or negative. And then 20. And now we must split this off into two parts. One where we add, the other where we subtract. So watch carefully as I do negative 11 plus 19 divided by 20. And I'll do x equal negative 11 minus 19 divided by 20. Okay? Now the trick to this is you do have to do the numerator first. You have to do the adding or subtracting before you do the dividing. Okay? So, I love my board when I can just take that and make it bigger. That's so cool to me. But I got negative 11 plus 19, call it 8 out of 20. And I've got negative 11 minus 19. Well, it says subtract, but the signs are both negative, so I really add negative 30 over 20. And there you go. Now, if you want to reduce these numbers, by all means, you could go to simplest form. You go to decimal form. 4 goes into 8 twice. 4 goes into 25 times. 30 over 20, well, take out the 10. Call it 3 out of 2. Still negative 3. So there you have it. In simplest form if it asks for it. All right, so I got one for you to try. I'll pull it back on the screen in just a second here, but go ahead and give that a try. I'll be here for any questions.